All right, so Unit 4, Lesson 2, Simplifying Radicals. This is going to be a very quick lesson because it is very simple, because every single radical I give you in this lesson is going to be perfect. Okay, so there's no trying to think of what number goes into it. That's a perfect square like we did in 4.1. We can just solve right off the bat. The only difference today is that I've added variables and exponents in there as well, and some different symbols and some fractions. We're just kind of amping it up a little bit. So the first question asks you the square root of 25, which is 5, but the only difference is they just want you to throw a negative out front. That's it. Okay, so all you do for this first question is write 5 with a negative out front. It just follows you down. Very simple. The answer is negative 5. Okay, now this one is saying it wants to give you to give both options, the positive and the negative answer. So for example, what's the square root of 49? 7, right? Like we can go 7 times 7 gives us 49. But guess what? There's another option that can give us 49. We can also go negative 7 times negative 7, right? That's still a square root. It's times itself, so negative 7 times negative 7, but that equals 49 still because two negatives cancel out. So there's actually two possible options. We've just always gotten used to writing the positive option, but the answer here, they want you to say what both options are. So the both options are positive 7 or negative 7, or if you want, you can just write the same, the same symbol they did. You can write it like this as well. Same idea. Okay. The square root of negative 1. Sorry, negative 1. Negative 81. What times what, that's itself, the identical number, gives you negative 81? What? 9 times 9? Well, what's 9 times 9? Isn't 9 times 9 positive 81? So that's not what we want. Okay, so I hear someone say, okay, one of them negative, one of them positive. So you want to do this, negative 9 times positive 9, right? Well, that certainly gives you negative 81. But again, what's the definition of a square root? It's something times its identical self. Are negative 9 and positive 9 identical? No, they have different symbols. You can actually use that option. It is impossible, you guys, to square root a negative. It's impossible. 9 times 9 is positive 81. Negative 9 times negative 9 is positive 81. And we can't do negative 9 times positive 9 because that's not the same number. It's not the definition of a square root. So whenever I ask you to square root a negative, freebie, it's impossible, okay? Okay, here I want the square root of x to the 14. Who remembers, this is from Unit 3, Lesson 6, when we did difference of squares, method 2 of factoring. How do we square root an exponent? What times what gives us x to the 14? That's the same thing. Remember when we did difference of squares, we always needed exponents to be even. That was one of our checklist things. Why did we need them to be even? Because what did we do to them? Tiana? Or I called you Tiana, sorry, Emily? We cut them in half, right? Because x to the 7 times x to the 7, we add exponents, right? So x to the 7 and x to the 7 makes x to the 14. And that's the definition of a square root, something times itself. So you just cut it in half. Okay, rolling up. E, same idea, don't get scared. We just do one at a time. The square root of 8 to the 40 would be a to the 20. Just cut it in half. Now, I put 36 for a reason here. A lot of students see, oh, 36, that's a perfect square. The square root is 6. And they write b to the 6. When it's an exponent, you always just cut it in half. So it's actually b to the 18. Okay, if it was a big fat 36, you square root it to 6, but exponents you cut in half. Okay, and this next example here, the square root of 100 x to the 10 y to the 18 z to the 24. Kind of a long one. I'll give you a second to write that down. Again, just do one thing at a time. The first thing is the square root of 100. What times what is 100? 10. So we take that out. Then next is x to the 10. So we cut exponents in half. So I have x to the 5. Next, y to the 18 cut in half is y to the 9. And finally, z to the 24 cut in half is z to the 12. Not so bad, right? We just do one thing at a time. All right, fractions, I know they scare us. Don't let them. We just do one thing at a time. Up top, the square root of a to the 10 would be a to the 5. And down low, the square root of b to the 14 would be b to the 7. Fractions aren't scary. One at a time. All right, I tried to make a scary fraction in H. I threw in a whole bunch of stuff. Can you guys see okay? I know it's kind of small. Should I zoom in a bit? Make it a bit bigger. So you have negative out front, and then the square root of 81 y to the 8, all divided by 144x to the 8. Okay. So what happens to that negative out front? Yeah, just gets added down. And now don't let fractions scare you, one at a time. Let's do the top. The square root of 81 is 9. And then y to the 8 becomes y to the 4. Down low, the square root of 144 is 12. And x to the 8 becomes x to the 4. Now, who's my super smarty pants in here who knows we're not done the answer? A jock? We can reduce the fraction. Right? You should always reduce fractions. So 9 over 12, what can I divide out of both of those guys? A 3. So if I divide both by 3, I still have the negative hanging out. So it becomes 3 y to the 4 and 4 x to the 4. And then we're done. So always just reduce your fractions, okay? All right, on to the next column. There we go. So I'm throwing in a bunch of different stuff with these guys, some multiplication, some fractions on the outside. So for this first one here, I want you to find the square root of 25 and then just multiply it by 4. That's all that means. So it's like there's really an imaginary multiplication symbol between the two. So it becomes 4 times the square root of 25, which is 5, 20. Easy. J, okay. We have a fraction on the outside. So this is like saying I want you to take 3 over 5 and multiply it to 11, the square root of 121. So we have 3 over 5, and it's now going to be multiplied to the answer here. So I always write it in brackets. That's just how I like writing multiplication. If you don't like that, that's fine. You can physically write that it's multiplication. That's fine. Now, a little review of multiplying fractions. Multiplying fractions is the easy one. No common denominators needed. All you do for multiplying fractions is multiply the top guys together and multiply the bottom guys together because there's really just a 1 on the bottom of that 11. All right, so then we just go on top, 3 times 11 is 33. On the bottom, 5 times 1 is 5. Easy peasy. Okay, this one here, fraction on the outside, 7 over 9, multiplied to another fraction, the square root of 16 over 49. So just take the square root one at a time. The square root of 16 on top is a 4, and the square root of 49 on the bottom is a 7. Again, we're multiplying fractions, so you multiply the tops and the bottoms. But does anybody remember a cool little trick with multiplying fractions that I can do here? Yes? Yeah, you can cross them out. If you have the same number up top that you do on the bottom, you're allowed to cross them off. That's only with multiplication. Okay? So then on top, what's left is just a 4, and on the bottom is just a 9. If you multiply them by 7, that's fine. On top, you'd get 28 over 63, but you just have to reduce in the end and divide out the 7. Okay, this guy over here, L, we only have 3 left. L says, I want the square root of 36 added to the square root of 49. Okay, so the square root of 36 is 6. And the square root of 49 is 7. We add them up. How easy is that? 6 plus 7 is 13. We can handle that. All right, so for these last two, I threw everything at you that I could. So I'll give you a second to copy down M and N, and then we'll tackle them. So for M, you guys, we have to really pay attention to what's going on and look closely and follow order of operations. You guys learned something called BEDMAS, right? We do what's in the brackets first. Well, we have 2 sets of brackets here. Let's look at the first bracket. We'll start there. In this first bracket, you have 2 radicals separated by a subtraction. So we're going to figure out what those are. So I want the square root of 196, which is 14. And then I want to minus the square root of 25, which is 5. And then don't forget this guy hangs out at the end of that bracket. Then I have this bracket, but look at this one. This one says I want the square root of this whole expression, not separate anymore. So I have to actually figure out the square root of 225. That's what that's asking. You see what I mean? See the difference? They're under the radical together. You add them up. So this first bracket, what do I do? I'm sorry? Okay, so very good. You're remembering last unit where something squared is itself twice, right? But remember, if we can simplify, let's simplify. That bracket in there is just 14 minus 5. We're allowed to do that. 14 minus 5 is just 9, isn't it? Right? So that saves us a little bit of work. It's actually just going to be 9 squared. But if you wanted to write it twice, it would still work. Like, it just takes a lot longer. Like Stacy, it would be like 14 minus 5 times 14 minus 5. And if you really wanted to, you could go 14 times 14 is 196 and da-da-da-da-da-da-da. But it's a whole lot easier just to go 9, right? So that's why simplifying is our friend. Okay, and then 225 is 15. So that's really what my question is. 9 squared times the square root of 25, which is 15. 9 squared is 81, so it becomes 81 times 15. And again, however you like to write multiplication, there's lots of options. Like I did brackets, that means multiplication, or you can do the dot, whatever you like. Okay, I'm just kind of showing you all the ways you can do it. Now 81 times 15 is your last step. Who can do that for me? 1,215. And we're done. Okay, last one here. I'm going to zoom in. We have 3 radicals. We have multiplication, we have subtraction, we have a fraction. Again, trying to throw everything I can at you. Get that down. The way I see this question, I see it like there's 3 people in it. 2 people on the top, they're minused, and then 1 person on the bottom. But first, this guy right here, we need to clean him up a little bit. So this is really asking 2 times 6. right? Square root of 36. Minus this guy would actually be 5 times 10, square root of 100. And down low, this is actually 7 times 9. I'm going to keep cleaning it up because 2 times 6 is actually 12. Minus 5 times 10 is actually 50. Divided by 63. Okay, so don't forget you have to complete the multiplications first. You have to figure out what all these guys are first. Okay, now on top, just simplify the top. 12 minus 50, well, that's negative 38. And on the bottom, 63, nothing's happening to that 63. You cannot reduce that fraction, so you are done. Okay, how's that today? Not so bad? Right, they're all perfect squares, so it actually works out quite nicely. So the assignment is a worksheet, and you'll have time on that right now.